Hello, another function that you are familiar with from your previous mathematical work, a quadratic equation. What's actually true about these quadratics, the general properties are also true of any even power. So x to the fourth, x to the eighth, x to the 1,000,000th, all those possibilities are all share the same basic properties. So here we go, digging in, page 4 of your big blue book. The domain of an even power function is all real numbers. Negative infinity to infinity, or you can write all real numbers, or you can do it in whichever format you like. However, the range is not all real numbers. It does not go below 0. When you square a number, it can never be negative. It can be 0 if you start with 0, but it can never be negative. So we can write this in a couple of different ways. We can write y is greater than or equal to 0. Or you could write it in interval notation as 0 up to infinity. 0 has a square bracket because it is included. That's the equivalent of the greater than or equal to. The infinity always has a curly bracket because you can never be equal to infinity. You can only get close to infinity. You notice that it intersects the x-axis and the y-axis at the exact same place. That is the origin, 0, 0, so that counts for both intercepts. There are no asymptotes. The key points on this graph, as you see, -1 and +1, 0, 0, 1, 1. Nice points there. It is symmetric, as you can plainly see, over the y-axis, which makes it, therefore, an even function. Not a surprise, because it's got an even power, and we called it an even power, so it's not a surprise that it's an even function. It is not 1-to-1, because there are, while each x point only has one y, there are y's that have more than one x. For instance, y equals 1 has two x values. X could be -1 or +1. Y equals 4 has two x values, -2 and +2, and many others. So there are many places where the same y value has more than one x value. It is not a 1-to-1 function. It is, however, continuous. You can draw it without lifting up your pencil. So everywhere from -infinity to infinity, it's continuous on the whole domain. -infinity to infinity. Its end behavior, as x is approaching +infinity, as we go out this way, x is approaching +infinity, so is y. We've got x and y both going to +infinity. On the left side, as x goes to -infinity, y still goes to +infinity. A negative times a negative is still a positive, and so y goes to +infinity both times. Whether x is negative, and whether x is going to positive or -infinity, y is going to both. Maximum and minimum points, as you can see, there is no max, but there is a minimum. The minimum is the vertex, 0, 0, not a surprise. Increasing and decreasing, remember we're talking about moving from left to right. So as you move from left to right, when x is negative, you are decreasing, moving left to right. I'm going down, and after 0, 0, after the vertex, I am now going up. So it's increasing. This function is increasing when x is bigger than 0, also known as 0 up to infinity. It is decreasing when x is less than 0, also known as -infinity up to 0 in interval notation. So from x is -infinity to x is 0, it's decreasing. From x is 0 to x is infinity, it's increasing. You know a couple of alternative forms of this equation. You know y equals ax squared plus bx plus c. As the standard form of a quadratic equation. You also probably remember that you had vertex form of a quadratic equation where you knew what the vertex was, and that is y minus k equals a times x minus h squared. Or you might be the kind of person who prefers the k on this side, in which case you'd add k to both sides and have a plus k over here. Applications of quadratics abound, especially in the real world. The two main places are area and acceleration, and gravity is a special case of acceleration that you will run into a lot in physics class this year and other places. There you go. So that sums up your even power parent function. Quadratic equations are one example of even powers, and that should take care of page 4 of your big blue book.